The last topic for Chapter 5 is comparing independent events versus not independent events. We're not going to call it dependent events. We're going to call them independent versus not independent. In order for something to be an independent event, the probability of that event occurring has to be equal to the probability of that occurring given something else occurred. You could write this either way. An event occurring probability of an event occurring is equal to the probability of that same event occurring given something else occurred. So basically it ends up being independent because that given event does not affect outcome. So if it fails, then it's considered not independent. So that would be where the probability of an event occurring does not equal that event occurring given something else. And I'll give you some of these examples. So that you can see. So when we look at the two examples that I have written here, I kind of put the independent one on the left and the not independent one on the right, which would end up working out. And you can kind of tell when you even just look at it. One card that you're picking from a standard deck. Set A is the card is red, and set B is the card is a 7. So when you first think about it, you say, okay, the card is red and the card is a 7. Let's calculate it. The probability that the card is a 7. There are 4 7s out of 52 cards, right? The probability that, you get a 7 given that you've picked a card that's red. When I was cut off on the video, I believe, for trying to figure out whether it's independent or not independent. Few things that I wanted to recap was that in this non-independent example, you can't get a red club. So that's where that 0 comes from. Even though they're mutually exclusive, doesn't mean that they're independent of each other. Just because these are overlapping doesn't mean they're independent. If you're going to know any terminology, it's best to know the terminology between independent and not independent. Not necessarily mutual exclusive.